So in continuation to our previous lecture, we had already learned that truss is a two force member. That means it is only able to carry the tension and compression, and the loads that will be acting on this truss will directly be acting on the joints only. The truss member is a straight member, so it is not able to carry any moment. Moreover, we have also learned that the forces will be acting away from the joints. Now let's see in this lecture how to do the truss analysis. So before starting this lecture, we would like to say that truss analysis can be done mainly in two ways. One is using joint method, which we will cover in this lecture, joint method, and another one is section method. We will not be covering section method in this lecture, so let's see the joint method. So here is an example of joint method. A truss is given, the vertical loads which is imposed on the truss is given, and here we are asked to determine the bar force member AB, AG, GB, GF and BF. That means the force that is going to be acting on this AG and AG, AB member, then GB member, GF member and BF member. So the force acting on this member needs to be calculated. We know that this member will be carrying the tension or the compression only. So let's see how to do this analysis using joint method. There are three steps mainly in order to do a truss analysis using joint method. We need to remember these three steps. Firstly, we just need to determine the support reactions. So firstly, the first step is to determine the support reactions. Secondly, we need to draw the free body diagram of the joints. Free body diagram, in short we can write it as FBD of joints. And thirdly, we need to apply equations of equilibrium. We need to apply equations of equilibrium. That means summation of f of x equals to 0 and summation of f of y is equals to 0 in these free body diagrams of these joints. And in this way, adopting these three steps, we can easily calculate the bar force members as well as complete our truss analysis task. So let's see. Here we can see the truss. We can see here the ADF truss, and the loads imposed at point G is 3 kilonewton, load imposed at point F is 2 kilonewton, load imposed at point E is 3 kilonewton. So here we are asked to determine the bar force member AG, GF, BF, AB. So what are the advantages of determining the bar force member? Actually, when we're going to design a truss for our structure, we need to calculate or do the truss analysis and determine the bar force member, and using that force member we need to determine the section. That means we need to select a section which will be able to carry the force that is going to be acted on this member. So without doing the truss analysis, it will not be economical to select the members or to select the section of the members. So let's see how to perform this truss analysis task. So according to our steps, the first one is determining the support reactions. So in order to determine the support reactions, here we can see this is a in support. That means it will be having two reaction, AX and AY. Here we can see roller support at point D, so it will be having only one vertical reaction, which is dy. So now applying summation of moment at D, summation of MD, considering clockwise as positive. So the forces that is going to act or create moment at point D are 3 kilonewton. This 3 kilonewton is rotating this point D in anti-clockwise direction, so it will be minus 3 into, and this 3 kilonewton, as we can see, these angles are 30 and 30. That means this 3 kilonewton is at a distance of 2 meter. As these angles are equal, that means it will be acting just throughout the middle portion. So the distance will be the half of 4 meter, which is 2 meter. So minus, as it is rotating the D point in anti-clockwise direction, so it will be minus 3 into 2. So we are getting it minus 3 into 2. Similarly, 2 kilonewton will also be rotating this member in clockwise direction. As the angles are equal, so we don't need to determine the distance. We can easily conclude that it will be acting throughout the middle section. So it will be 4 plus half of 4, which is 2. That means 2 into 6 in total. In total it will be 6 meter. So 2 into 6, it is rotating the D point, rotating about D point in anti-clockwise direction. So it will be minus 2 into 6, as we have considered plus clockwise as positive. And again 3 kilonewton is rotating about D point in anti-clockwise direction, so it will be 4 plus 4. And as again these angles are equal, so the value of this portion will be 2 meter. So in total it will be 4 plus 4 plus 2, in total 10. So minus 3 into 10, as it is rotating about D point in anti-clockwise direction. And lastly, we can see here AY will be rotating about D point in clockwise direction, so it will be AY into the distance in total, which is 12. So AY into 12. And as the AX point is acting along this, acting towards D point or in same direction as in same line, that means it will not be having any perpendicular distance with point D, and that's why it will not give any moment with respect to point D. Now from this summation of MD equals to 0 equation, we can easily calculate the value of AY. So we can see here the value of AY is 4 kip, which is acting in upward direction. And similarly, applying summation of f of x over here, x equals to 0 over here, throughout the entire truss, we are applying summation of f of x equals to 0 throughout this entire truss, and from here we can conclude that the value of AX will be equal to 0, as all the loads acting on this truss are in vertical direction. There is no lateral forces, that's why AX equals to 0. And similarly, if we want to apply summation of f of y is equals to 0, and we will get the value of dy as well. So the value of dy will be 3, 2 and 3, which is in total 8. So here you can see 4 kip in upward direction, so another 4 is required, so the value of dy will be also 4 kip. So in this way we can calculate the support reaction. And now we need to move forward to our second step, which is drawing the free body diagrams of the joints. So as we are asked to calculate the AB, AG, GB and GF, BF, that means AB, AG, GF, GB and BF, these 5 members in total. So we need to consider this joint A, so these two members are connected in joint G. So let's draw the free body diagram of joint G, also joint A. And then as these two members are connected in joint B, so also we need to draw the free body diagram of joint B. As we have mentioned earlier, the forces that are going to be acting on these joints will be away from the joints. Always these forces will be away from the joints. So we can see at point A, or at joint A, there are two member forces, which is AG and AB. So as we need to denote away from the joint, so denoting it with FAG, force acting at AG member, which is FAG, away from the joint. And similarly, force acting in AB member, which is away from the joint, which will be FAB. Similarly, we need to draw the free body diagram for G joint as well. So for G joint, we can see here 3 kilonewton load acting in vertical direction. And now if we want to draw a straight horizontal line over here, we can see that as this is 30°, this angle is 30°, so this will be the alternative angle. So this alternate angle will be also 30°. And similarly, as this is 30°, and this will be the corresponding angle of this one, and it will also be 30°. So these two are denoted with 30 and 30. And if we draw another horizontal line, continue this horizontal line, so as this is 30°, so this will be the alternate angle, and it will also be the 30° one. Now drawing this free body diagram for for joint G, you can see the associated members which are connected to joint G are GF. So member force acting along GF, which is FGF, it has also been denoted away from the joint, which is our convention. And member force GB, so GB, FGB. And for AG, which is member force AG away from the joint. And similarly, we need to draw the free body diagram for joint B also. So this is the diagram for joint B as well. Now we need to apply the equilibrium equations, which is summation of f of x equals to 0 and summation of f of y is equals to 0, which is our third step. So now we need to apply the equilibrium equation for each of the free body diagrams. So now, considering for joint A, if we want to apply summation of f of y is equals to 0 in this joint A, we can see that FAG is an inclined force, which is inclined at 30° with the horizontal one. So in order to calculate its vertical component, we need to consider its sine 30 portion. So as the angle is given with the horizontal, so its vertical component will be the angle, sine angle of that is given with the horizontal one. So sine component, as it will be the sine component. That means its vertical component will be FAG sine 30. So FAG sine 30, it will be its vertical component. And we can see here another vertical force, which is y directional force, which is +4. So +4. So in y direction there is no other forces. So from here we can easily calculate the value of FAG. And now applying summation of f of x equals to 0, and we can see here that this FAG component will be having a horizontal component. It will be its cos component, as the angle is given with the horizontal one. So FAG cos 30, which is acting in right direction, that means plus, positive. And FAB is also acting in right direction, which is positive. So FAB, so the summation of these two will be 0. And as we have calculated FAG earlier, now we are going to plug it over here, and plugging the value of FAG, we will be getting the value of FAB. So the value of FAB will be plus 6.92 kip. So here we can see that the value of FAG is minus 8 kip. That means the AG member, that means this AG member is in compression, and the value of compression is 8 kip. Similarly, the value of AB has came from our calculations, plus 6.92. That means the AB member is in tension, plus 6.92, and the value is plus 6.92. Similarly, applying the same procedure for point G, that means we need to apply summation of f of x, summation of f of x, and summation of f of y for joint G. Now applying summation of f of x first, we can see this is an inclined member, so it will be having a x component, its horizontal component, which will be cos 30. So FGF cos 30 for this component, and for this FGB there will be also a cos component which will be acting along the horizontal direction or in x direction, so FGB cos 30. And now similarly this FAG will also be having a horizontal component, which is its cos component, so FAG cos 30, but it is acting in left direction. We have considered right as positive, so minus FAG cos 30 will be equal to 0. Now from here we can see that in our earlier stage or earlier step we have already calculated the value of FAG. Now plugging the value of FAG over here, so plugging the value of FAG, we will get a relation in between FGF and FGB. So our relation will be something like minus 6.92. So here we are getting a relation, so giving or denoting it with equation number 1, denoting it as equation number 1. And similarly, applying summation of f of y is equals to 0, we can see here 3 keep load is acting downward, that means minus 3, minus 3. FGF, it will be its sine component in vertical direction, so FGF sine 30, and FGB, so it will have a vertical component which will act downward direction, so it will be FGB sine 30. So as it is acting in downward direction, it will be minus. Now similarly, FAG will also have a vertical component in downward direction, so it will be FAG sine 30, and as it is acting downward direction, it will be minus FAG sine 30. So in this way we have formed this equation, and we can see that the f of FAG value, we already know the value of FAG, and from here we will also be getting another relation for FGF and FGB. So now from this equation number 1 and equation number 2, using calculator, as we can see that in these two equations we had just two unknowns, FGF and FGB. So using our calculator, we can plug the value of cos 30, sine 30, sine 30, and cos 30 as well. Now we just have two unknowns, so two equations are available, so two equations and two unknowns, so we can easily calculate the value of these two unknowns. We can see, solving these two equations, the value of FGF will be minus 5 kip and minus 3 kip for FGB. So we can say that if GF component, GF member is in compression and the value is 5 kip, and GB member is also in compression and the value is 3 kip. Now for joint B, applying summation of f of y, we can see at joint B in vertical direction there is no forces, but it will, the inclined forces FGB and BF will have vertical components. So as the angles are giving with the horizontal one, so it will be having its sine component in vertical direction, so FGB sine 30, which is acting in upward direction, so FGB sine 30 positive, and FBF sine 60, which will be acting in upward direction, so plus FBF sine 60 will be equals to 0. So from here we can see that in our previous step we had already calculated the value of FGB. So plugging the value of FGB over here, we will get the value of FBF. The value of FBF will be plus 1.73 kip. which is in tension. So similarly, applying summation of f of x over here in point B, joint B, we will get the value of FBC as well. In this way, we will solve for each of the force bar force member and for each of the joints as well, using each of the joints as well. And similarly, in our example 2, we are asked to determine the bar force member AB, AG, AB, AJ, AB, AJ, and AK, AK, KJ, and BC. These members. Now, according to our steps, that means firstly we need to calculate the support reaction. Here we can see pin support and the roller support over here. Applying summation of moment, we will get the value of AY, but here we can see a lateral force, so the value of AX will exist. So applying summation of f of x equals to 0, we will get the value of AX as well, and applying summation of f of y is equals to 0, we will also get the value of EY. Now, as we are asked to determine these members, so you can see these three member AK, AJ, and AB are connected in a joint. So let's draw the free body diagram of A joint, and now here you can see that AB and BC are connected in B joint, so we need to draw the free body diagram of B joint also. And then AK and KJ are connected at K joint, so we need to draw the free body diagram of K joint also. Now, applying summation of f of x and summation of f of y in each of these elements, each of the joints, we will get each of the values. We had done it in our previous example, so it is actually the same procedure. So firstly, starting with K joint, if we want to apply summation of f of x, we will get the value of fkj as equal to 0, and similarly the value of fak, that means y directional forces. As there is no y directional forces or loads, the value of fak will be equal to 0. Now, for similarly, we can complete the task by applying summation of f of x and summation of f of y at joint A and joint B as well. In this way, we will conclude our truss analysis. Thank you.